Here's a quick example on how to use the sine, cosine, and tangent functions. First of all, anytime we use a sine, cosine, or tangent function, it always has to be done with a right triangle. There always has to be at least one right angle somewhere in each of these triangles we solve for. Alright, now that we have our triangles, you also have to know 2 out of 3 things. We have to know 2 things about a triangle to solve for it. If we know 2 sides, like say we know the hypotenuse and this side here we'll call A, we can find out more about the triangle. In this case, we could find this third side. For that we use the Pythagorean theorem. This video is intended on how to use the sine, cosine, and trig functions. And in these, we always deal with an angle. If you know an angle and you know one of the sides, say this adjacent side over here, then you can solve for the length of any others. Okay. So let's go down this triangle and actually use some numbers. Let's say this angle here is 45 degrees. And we know the length of this side of the triangle. We know it's 15 centimeters. We want to find out the length of this side here, which is the hypotenuse. To do this, we first have to understand the acronym SOHCAHTOA. This will tell us which one of the trig functions to use. I see that I have a value on the opposite side of the triangle from the angle. I also see that I want to find the hypotenuse. Whichever one of the parts of the SOHCAHTOA have the O and the H is the function we're going to use. O and H, so we're going to use the sine. And this part here reads as such. The sine of the angle, that's what the S means, is equal to the O over the H. We want to find the hypotenuse, so I have to solve this equation for H. To do so, first multiply both sides by H. H's cancel. I have H sine of the angle equals the opposite side. Now divide both sides by the sine of the angle. Oop. No equal sign there. And we find out that the hypotenuse, the length of it, is the opposite over the sine of the angle. The opposite is 15 centimeters. The sine and the angle is 45 degrees. This is what we need to put in our calculator. The sine of 45, 45, sine, where is sine? There's sine. The sine of 45 is, come back, 0.707. 0.707 and 15 centimeters. So this is what we need to put back in our calculator. Clear it. 15 divided by 0.707. 21.2. 21.2 centimeters. So that is the length of the hypotenuse here. 21.2. Let's try another one. Here's our right angle. Let's say we know this one up here. We know this to be 30 degrees. We also know, in this case, let's just say we know the length of the hypotenuse. It's 9 centimeters. If we want to find, let's find this one here. I'm going to say this is the A side. I call it the A side because it's the side right next to the angle. It's not in the opposite side of the triangle, it's adjacent to it. We want to know the adjacent side. We know the hypotenuse, A and H, so we have to use cosine. And this reads the cosine of the angle, that's what the C stands for, is equal to the A adjacent over the H, hypotenuse. We want to find A, so we have to solve this equation for A. Multiply both sides by H. We H cosine of the angle is equal to the adjacent side. Oh, there we go. 9 is H, 9 centimeters, times the cosine of the angle is 30 degrees, equals A. Come out to our calculator, cosine of 30, clear it, 30 cosine, 0.866. 0.866. 9 centimeters times that is A. So I'm going to take this value, multiply it by 9, 7.79. Check that, 7.79, yeah. 7.79 centimeters. So that would be the length of this side here. We could do another example if we needed to with this triangle here. And we knew the angles. We knew this angle here. But in this case, let's say that this is 5 meters. We want to know the side here. It's on the opposite side of the triangle. The opposite side, the adjacent side. We'd have to use the O and the A, the tangent. This one would read the tangent of the angle is equal to opposite over adjacent. We'd have to solve this equation for O, plug these numbers in, solve it just like we did before. There's an example of all three functions.